Hey scholars, Quadratic Formula Day. So we're going to take a look. Now, last week we looked at looking at how to solve quadratics with square roots, and we've noticed that you could basically take uh, any equation in vertex form and you can solve that with square roots. So you can go backwards and take the steps backwards, and really that's really what a formula is where you're doing the same thing over and over again, and you can just simplify it. So you could just plug in the numbers, put all the things together in one step. It saves you some time. And so the question that we want to look at is, well, what about standard form? What about standard form with the form uh, y equals ax squared plus bx plus c? How can we get that? How can we get that into a form where we can just find the solutions? We can find the roots or the zeros. And so, if you remember from standard form, at least the x coordinate or the axis of symmetry is negative b over 2a. Now, if you actually plug that in to the standard form and just work it out with variables, you'll find that the y coordinate is going to be b squared plus 4ac divided by 4a. Now, that seems a little complicated, but the idea here is that we can really get the vertex of any quadratic from the standard form. So if you can do that, well then theoretically you can put this in standard form then with the x and y coordinate of the vertex, and then you should be able to work backwards and solve it. So I'm not going to go through every step for this, but if you want to figure out, you could probably work this out algebraically. It's really just reversing the steps and doing some simplifying. But if you want to Google the how to prove the quadratic formula, you certainly could. See if you could actually replicate the steps. Might be an interesting little activity for you. But the idea is that there's a formula then that you can see here on the right that actually will work then for any equation in standard form. So the quadratic formula then is a way that you can find roots, zeros, x-intercepts of a parabola if it's in standard form, and it sort of saves us those steps of having to put it into vertex form and then work backwards. So it's pretty simple, straightforward. It just needs to be in standard form where it's equal to 0, and then we can certainly identify a, b, and c. So in this case, for the first example, a is 1, b is -5, and c is -36. So then we're just going to substitute into the formula. The formula is over there on the left-hand side. So again, you might have heard this in algebra before. There might be even a song to it if you want to go back and do that. I'll save you that song for me. But really, what you want to do then is we're going to put this into the form. The opposite of -5 is +5. We'll do what's underneath the square root, which is -4 times -36, and that would give us our form. Now, I suggest simplifying what's underneath the square root first, so you can see we'll get 25 plus 144, and then we can simplify that and take the square root. In this case, that happens to be a perfect square, so the square root of 169 is going to be 13. And then at this point, we're going to have two answers. And so if you were typing in an answer on Delta Math or something like that, you can hit the little plus button and make it two answers so that you can type them in separately. And then clearly the answer here, 5 plus 13 is 18, divided by 2 is 9. And then 5 minus 13 is 8, divided by 2 is 4. Sorry, -4. And it doesn't matter the order that you type those in. It should be one or the other for that. So we're going to do a few in the examples below, and then if you want to do some more for practice before you do your assignment, I'll upload the answers to that in the folder for today. So let's just take a look at the next one. Notice that the next one is not in standard form, so in order to put it in standard form, we're going to have to subtract 20 from each side. That will put it in standard form where it's equal to 0. That's what it needs to equal. And then we can identify A, B, and C. In this case, A is 1, B is -8, and C is -20. So if we put this into our formula, and you can see that we're going to again have two negatives multiplied together. We get 64 plus 80 divided by 2. And so again, work inside the parentheses, inside the square root first. Imagine that as a big set of parentheses that you can do with that. And then we'll end up with 8 plus or minus the square root of 144, which is also a perfect square. So we end up with some rational solutions here, and we'll end up with 8 plus 12, which divided by 2, which gives us positive 10, and then 8 minus 12 divided by 2, which gives us -2 for that one. So if you look at the next one, we do have to put this in standard form as well and equal to 0. So in order to do that, you have to subtract 9. And so here is the work for this problem. And you can see that we'll end up with, again, we happen to end up with a perfect square. And so some of these answers that you'll see today will end up being perfect squares. Some will not. In this case, the square root of 121 is 11. Now, notice here that when we go ahead and subtract, or when we add, we're going to end up with a value of 1, and then when we subtract, we'll end up with a value of -18 over 4, which you then can simplify and reduce to -9 over 2. So again, most of the time we want to get in the habit of reducing and simplifying fractions. We also want to take a look then at the second page of the notes, where we're going to have irrational solutions, which means that what you're going to end up with is you're going to end up with a square root that is not a perfect square. So we'll talk about how to deal with those and simplify those, and how to type them in if you're using a Delta Math or a computer assignment like that. So when we go ahead and tackle number 9, notice that A is 1, B is +4, and C is 1. So when we end up with the square root, we end up with 16 minus 4, which still gives us a positive answer, which will tell us that it does cross the x-axis twice. But we end up with the square root of 12. Now, the square root of 12 is not a perfect square. However, it can be simplified, and you can simplify it by taking the square root of 4 times the square root of 3. So the square root of 4 is 2, and then the square root of 3, and then this is all divided by 2. So when you do that, you'll want to notice the 3 terms. They all have 2 in common. You can actually you can factor out 2 out of all 3 parts, which will be 2 over 2, and that will simplify so that we can end up with -2 plus or minus the square root of 3. And it is just the square root. It's -2 plus or minus the square root of 3. You don't have to type them as separate answers. Most of the time, if you're typing in an answer, it will have the plus or minus button that you can push to put this in irrational form. So the last one we'll do is number 12, and just take a look at that one. Again, we'll have to put this in standard form first, so we end up with the value +2 as C. And so if we use the quadratic formula again, you don't have to, you can just use a regular calculator for this. We'll end up with a underneath the square root 49 minus 32, and if we do that, 49 minus 32 is 17. Now the square root of 17 is 17 is a prime number, so it doesn't have any factors of it, not even a square, perfect square. So when you when you have an answer like that, you're just going to keep it as 7 plus or minus the square root of 17 over 8. We really can't simplify that anymore. And you can actually type this answer in just as it is. So you can leave it as a fraction with that. So again, go ahead and attempt some of these others just for practice. And then if you want to check your notes, the completed notes are in the folder for today.